Okay, the first of the simple machines we want to look at is the inclined plane, or as we commonly refer to it as, the ramp. So I need to get this power washer into this crowded shed, which, yes, has can jam in it. And I have two choices. I can either just pick it up and put it in there, or I can use the ramp. So the question is, how does the ramp actually help us do that? Well, let's have a look at how much the power washer actually weighs and how much work it would be to lift it up. Okay, so now let's pull the power washer up the ramp and see how much force that takes. I can do that with one hand and with about 60 to 70 newtons of force, somewhere in and around there. Now this ramp has these little corrugated openings in it, which adds a little bit to the rolling friction, but I was able to one-hand that and get it up the ramp. Okay, so now that I'm in the shed, I was able to hang the pressure washer from the scale, and we can see that it has a weight of 229 newtons, and yet using the ramp, I was able to pull it up with around 70 newtons. So how this worked. Lifting the power washer directly into the shed was about 57 joules of work, because it had to go up 1/4 of a meter. That's about 25 centimeters high, and it had a weight of 229 newtons. So it's roughly 1/4 of that is what the work is, because it's 0.25 meters times 229, and you end up with about 57 1/4 joules of work. That's just to lift it straight up into the shed. Now the ramp gives you 57 1/4 or 57.25 joules of work by raising the power washer up into the shed for you. But you have to do a little more work in order for that to happen. So I used about 70 newtons of force, and I had to drag that up 2.5 meters. So I did about 175 joules of work on the machine. The machine gave me the 57.25 joules of work I needed. So yeah, it was more work for me, but it was much easier work. I was able to do it with only about 70 newtons of force, and I was able to do it with one hand. Whereas if I tried to pick that up and put that in the shed, I definitely would have had to use two hands. And I know that's such a minor thing for a power washer, but just imagine if you were moving a large piece of furniture into a moving truck and you had to lift it up into the truck. That's why the U-Haul trucks and that give you a ramp to make it easier for you to do the work. So that's how an inclined plane helps make work easier. Okay, so machine number 2 is the wedge. Now, you might be looking at the wedge and thinking, hey, that looks an awful lot like the ramp or the inclined plane. And you're right, it does. It has the same shape, that triangular shape. The only difference is the ramps usually have a 90-degree angle right here, and this one does not. This one has the same angle here as it does here, so it's not a right triangle like a ramp is, but it does look an awful lot like a ramp. In fact, I can even use a wedge as a ramp if I want to. Here we could see Night Monkey is going to demonstrate how the wedge can be used like a ramp, and let's see what happens here. Yay! Ah! Night Monkey, you learned nothing from the Newton's Laws videos and you fell off the truck. And then it looks like it's on your foot too. That's going to be painful. You're going to have to walk that one off. Difference then between the wedge and the ramp, other than the angle thing, the difference is that when you use a ramp, the ramp is stationary. When you use a wedge, the wedge actually moves through whatever it is you're trying to split. So here's an old rotted stump from a tree that was taken out a long time ago, and you can see I could just jam the wedge right through there and stick it in there. And then you would take a sledgehammer and just hit the top of this. You can see how the top of this is actually kind of deformed and chipped up a bit from all the times it has been used and struck with a sledgehammer. And you just drive that through the piece of wood. And what you see is that ideally, if there was no friction to anything, the mechanical advantage of this would be the length of the wedge divided by the width of the wedge. Because in order to split the wood this far, you have to drive the wedge this distance. So that would be the ideal mechanical advantage for the wedge. And it works pretty much the same way the ramp does. It's extending your distance over which you're applying your force. But the big difference again was the wedge moves and the ramp doesn't. Machine number 3 is the screw, and the screw is kind of like the inclined plane and the wedge combined. It's almost like a hybrid of the two. You have a lot of the screws will have a point, not unlike a nail. You drive the nail into something, it's got a wedge point in it so it can pierce through the wood. This particular screw does too. Not all of them do. Some of them, the holes are already drilled out for them, so they just have the threads. But you could think of a screw as like a nail with an inclined plane wrapped around it. Now you might be saying to yourself like, well, why isn't it a wedge wrapped around it? Well, the wedge would be, 2 points coming to the middle, and you would have the threads all meet in the middle of the nail if it was a wedge. So it's got to be more like an inclined plane. So what I did to demonstrate this is I made a little paper inclined plane. Ta-da! Isn't that amazing? And if we were to wrap this around the nail, I'm just going to take a little piece of tape here just to help get it started. If we attach this to the nail like that, and we just start wrapping it around, you can see how the threads of the screw are just like this inclined plane wrapped around there. But it's also kind of like a wedge in that the screw is what goes moving through the wood. Now, I mean, you can look at it and say, like in some cases, maybe the screw is pulling something up. Either way you look at it though, that's how it works. And the mechanical advantage is dependent on what angle these threads are on and how close they are together. The greater the angle, the fewer threads you'll have. For example, I made another one, which if this was a ramp, this would have less of a mechanical advantage than this ramp did, because this ramp was so much longer. They both go about the same height, but this one is at a sharper angle. So if you wrap this one around a nail, let's just get a little piece of tape. Whoops, hit the camera. Rookie mistake. And we wrap that one around the nail. You can see the threads are more spread out than they are in this one, and that would give this one less of a mechanical advantage than this one. So that's basically how the screw works. You could see different screws for different applications. This one has a tremendous mechanical advantage because the threads are so close together, and it's like they're barely on an angle at all. It almost looks like they're going straight across, but if you look, they are sloping down a little bit that way. And what that means for you, because this is all about extending your distance to make the job easier so you can use less force, is with this screw, you would have to turn this one many more times to get this through whatever you're putting it through. This one would require less turns to get it through the wood, but you would have to use a little bit more force than you would on this one. So that's why a screw is kind of like an inclined plane and a wedge mixed together. The next 3 machines will be different. The first 3 machines were all kind of similar.